So when you're working with absolute value equations, there's actually two options. The first thing that we could put in here is that 3. When we had a positive 3, it came out as 3. But we could also put in a negative 3, and it comes out as 3. So there's actually two answers. The first one is just normal, that positive 3. The second one is that negative 3. So when you're working with an equation that has a little more to it, or you might have to do some opposite operations, you're going to have to actually write out two separate equations to get your two answers. Let's make it a little more complicated. So if you have something like this, absolute value of x plus 4 equals 7, you have to actually write out two separate equations to solve this. And you don't have to write the words equation 1 or equation 2. This is just to show you, there's actually two equations here. And we're getting this from the concept of, well, one of our answers was the positive 7. So this equation 1 looks almost exactly the same, just no absolute value bars. And then the second equation, the equation 2, has that negative version. We had that negative possibility. So you actually have two separate equations to solve now because you get those two separate answers. The first equation, when you solve it, we do our normal opposite of operations. If we're adding 4 here, what's our opposite of addition?
Subtraction. I know you couldn't hear me. Sorry.
I'm not sure why it wasn't working before, but it's definitely working now. So subtraction, to get rid of it. So that gives us our first answer. So when it was super simple, that the two answers looked exactly the same, but just one positive, one negative. When it's more complicated, when we do our opposite now, it's going to give you a different number. It's not even going to be a 3 anymore. What do we get when we do the negative 7 minus 4 for our second equation?
That's going to give me, let's give me a negative 4, negative.
It's going to be a negative answer.
Yeah.
So negative 7, not a 3 this time. When you have negative 7
and
minus a 4, it's
11.
like it's like you add the numbers but keep the negative sign. Negative and positives have so many rules, it's hard to remember which one to use where. So we still get these two separate answers. So absolute value equations, you have to remember yourself. I have to write two separate equations because of these absolute value bars.
You had to do it to every problem, or?
Yes. To every problem, you have to write two separate equations.
So you give me two separate answers?
Yep, it's going to give you two separate answers. The only possibility, sometimes there's two answers that look the same. This one is still two separate answers, but one's positive 3, one's negative 3. That doesn't happen very often. Usually it's two completely different numbers.
Okay.
Something else that can be kind of weird that might kind of switch it up a little bit is they write the absolute value bars on the opposite side. If they do that, I would actually rewrite it. I'd put the absolute value bar first and then put the number. But once you do that, now you just write your two separate equations again. So what would the first equation look like?
The one inside the 2x plus 4.
Mm-hmm. And what did it equal?
5.
5. So the first one looks almost exactly the same. We just don't use the bars anymore. How did we change the second equation? What made that equation different?
I will do that, but they put -5.
Exactly.
I mean, -5, sorry. Yeah.
It's about the same thing. I know when you mean minus.
I know.
Yeah. Yeah. Okay, so now we have two separate equations to solve again, and we just go through doing our opposites. So what opposites should we do for equation 1?
Yeah, let's do the... I'm stuck.
Okay, if I just gave you the equation 2x plus 4 equals 5, nothing else involved, no absolute value, nothing else on the screen. When you do your opposites, we always focus on the addition piece first. So we do the opposite of that.
Yeah, but you have a whole number. It's a +5.
Mm-hmm.
And what you do on one side, you have to do on the other, right?
Yep. So we do -4 on both sides to get rid of it. We did it to one side and to the other. Does that make sense?
Yes.
Okay. And then this equation has one more step. How do we get rid of that 2? What's the opposite for the 2?
You either do 2 also, or
Are we going to
1
minus
is the value of the x, even if they don't have it obvious, but you can do that.
Say that one more time.
Even if you don't have an obvious 1 value of the x, we can put it over there, right, next to remind us.
So yeah, we can't figure out the value as easily just by looking at the x. We have to do the opposite.
Exactly. And now it's going to be, value is 1, it could be 2 times 2. 1 is going to be 2. There we go.
Well, 2 times 1, so this
I mean 2 times 1, sorry.
This is multiplication, so instead of doing 2 times 1, we actually want to do division. We have to do the opposite of multiply.
Oh, I got it now.
Which is divide. So we have to do 1 divided by 2, which gives you a decimal. 1 divided by 2 isn't a nice number, so we would have to use a calculator. Or some people have this one memorized because it comes up a lot. But 1 divided by 2 is 0.5. Good.
0.5.
So the first answer.
Manuel, that's my oldest son. Huh? You know the chicken here, you over here. Yeah. Okay.
Okay.
Sorry.
No problem. So then how about the second equation? Now we have to go through the process, but with this equation.
We do pretty much the same thing.
Pretty much. The only difference is we get different numbers. Because when we do -5 minus 4, instead of getting 1, what do we get?
Where on the bottom, we get 2.
Well, we brought down the 2x. When we do the -5 minus 4, we need to do that calculation.
You have 1.
That's what we get when it's +5 minus 4. What about -5 minus 4?
-1.
Not -1. Remember, it's like you add the numbers when they're both negative.
9. -9. Sorry.
-9. Those integers really can get you. So I recommend always plugging it into a calculator just to double check. I still screw it up a lot of the times because there's just so many rules to remember on it. Okay, and then we do the same last step as last time and divide by 2. So what's our second answer? It's going to be a decimal again. What do we get when we do -9 divided by 2?
4.5.
-4.5. So this problem has two answers, 0.5 and -4.5.
Thank you.
So,
rolling out the door right now, so, but I appreciate it.
Yeah, thanks for coming for a little bit, and hopefully I'll see you next week too.
Yes, I will.
Okay.
Thank you.
Bye.